On behalf of ATAL-FDP, Department of CS&IT, Maulana, a warm welcome to all the participants in the Day-1 second session. It is my pleasure to introduce our speaker, Professor Anil Kumar Chaudhary sir. Professor Anil Kumar Chaudhary is the Professor of Advanced Center of Research in High Energy Materials, HCU, Hyderabad. He did PhD in Non-Linear Optics, Gurdwan University, West Bengal, India. His area of research includes non-linear optics, laser spectroscopy, tunable laser-based photo acoustic sensor for atmospheric pollutants, development of multi-pass liquid sand for the study of the water pollutants, combustion and thermal decomposition, study of organic fuels. He has published more than 130 research papers in national and international conference and journals. He has worked on various research projects such as development of tunable laser-based photoacoustic sensor (DST), development of multipass liquid sand for the study of water contaminants (DST), development of tunable laser-based techniques for molecular biomakers (DBT), Ministry of Science and Technology, Government of India. Now I would like to invite Professor Anil Kumar sir to begin today's session.
Good afternoon and first of all, I would like to express my sincere thanks to Dr. Professor Kumar and Professor Wahid for giving me this opportunity to interact with you. So today's lecture, it is just introduction type of what is called the lecture, where I will try to give the flavor of some of the deep what is called the science of quantum computing. So you already got my introduction, but basically we people are involved in terahertz technology development, and we have developed our own imaging system, and now we are working for development of the radar and many more new technology. So my lecture is divided into two parts. First part I will give you the what is called the brief, or the brief and the detailed aspects of quantum computing, which is a mixture of optics, electronics, non-linear optics, and many more things. So many of places I work, many places you people are working. So let us try to understand how the technology works. And the second part, I have my research scholar, Kumar, is a SRF. So he is involved in what is called artificial intelligence-based development of detection system. So this is based on our own system. So that is a technical part, and Naveen will compensate the gap of this knowledge of theory and experiment. So he will provide us the detailed information and how the AI works to identify the hidden exposure and other type of the biomolecules present in the matrix. So let me tell you about my center. This center is established by it's a brainchild of Bharat Ratna Dr. Kalam. So he wanted that the center should be established in the academic institution, defense center. So first center came in 2005 and 6. So we were the first batch of faculty who joined with our founder director, Professor Chaudhary. And we started our journey with the zero. There was not a much facility. Only fund was available, but fund was free flowing fund. So we have been given free access, and from zero to now you can come to our center, we can show you what type of facilities you have developed. So when we are talking about this quantum computing, so very fast. So you can see there are three parts because there are multiple verticals in this talk. So I try to cover one by one, and if you want I will go back. You can ask a question, I will try to address this question. So In first part, we are going to discuss the classical computation and devices, an idea of quantum computing, and how this idea came in the picture. In the second part, what is quantum computer and comparison of the smallest particles. And the third is the advantage of quantum computing, optical quantum computing, and what is called the quantum computing universal. So these are the three parts. And when we are talking about the quantum computer technique, only like this. Okay. So when we are talking about this quantum computer, the computer that uses the voltage going through the circuit, because this is a normal computer system what we are using in our daily life, which can control and manipulate entirely the classical mechanics, and it is basically controlled by the Moore's law. You already know. The Moore's has given the formula that every year you can double the number of the component in the chips, and using the same formula, the supercomputer came in the picture. But this is the old technique, and now the Moore's law is also getting saturated. So the new picture came, and this picture came. But if you see the journey of this technique, this is perception. The hypothesis started in 1900. I will tell you what is the history. So let us compare first what is the difference between classical computer and the quantum computer. So classical mechanics, it is based, because they are talking about a quantum computational technique, so it is based on a quantum mechanics. And what is quantum mechanics and how the law of entanglement of photons works. So before that, let us discuss or compare the difference between the classical mechanics and the quantum mechanics. So how many of you are having the background of physics? I mean the MSc or something like that. All are engineers, right? Anyhow, so you read the physics. You cannot say that you do not know physics. Physics is compulsory up to first year, right? So you already been given some information. So physics is basically divided into three fundamental mechanics. One is the classical mechanics, one is the quantum mechanics, and the third one is the statistical mechanics. These are the three foundations of a basic physics, where the mechanics is discussed or developed. So it is an ideal and microscopic particle system when we are talking about the mechanics, classical mechanics. And this is a macroscopy. It is dealing with the component, big size of component. Wherein quantum mechanics is ideally a microscopic particle. So what microscopic particle is, you think about it in terms of photons or photons. Then it is based on the Newton's law of motion and Maxwell's electromagnetic wave theory, which is a principle the law of physics, which is applicable for all classical mechanics or propagation of electromagnetic radiation. However, in case of the quantum mechanics, it is based on the Schrodinger equation, and it works on the Planck's postulates. So Planck was the first person who predicted the dual nature of light, where the light is having a dual nature. It can be treated as a particle, it can be treated as a wave. And particle nature is known as a quantum nature. Then, the most important, any amount of energy may be emitted or absorbed continuously. So in classical mechanics, generally it is the assumption that the amount of energy may be emitted or absorbed by the system, it is in a continuous or a random manner. But however, in case of a quantum mechanics, because the Heisenberg uncertainty principle came in the picture, and that basically based on the de Broglie materials hypothesis. So here the energy level is discrete. It comes from a different level of atoms. The state of system is identified exactly by specifying their position and the velocity, where here we are talking about the orbit. So suppose you take a hydrogen atom or the sodium atom, where you can find one nucleus in a hydrogen, and then you have a one orbit where the electron is there. So it is divided into two parts. If you follow the rule 2n square, so it can be increased with respect to the number of atoms in the system. then the future state can be predicted with certainty. But the only thing is that whatever calculations or things we are doing in a classical mechanics, it can be predicted because there is a limitation. However, in case of a quantum theory, it is a probabilistic in nature. So whatever the things we are doing or we are going to use in the system, it is a probability based. That's why the psi function is used in my lecture. Sorry. So concept of the quantum mechanics came given by Professor Hyman. He was the Nobel laureate, and the person he expressed the possibility of quantum computing in 1982. So according to his idea, a machine can be created which can based on the quantum mechanics law. And since Hyman is one of the genius physicists of our time, and while giving this idea, he followed the process of 19th century. I will tell you how it is started. And then 1985, David developed a quantum turning machine, which is showing the quantum circuits of universal. So 1982, the idea was floated, and Hyman has confirmed that this type of computer can be designed. And 85, David Judge has basically developed a quantum turning machine. Then 1994, the algorithm was developed. It is known as the Petersdorf algorithm. So he developed the quantum algorithm. And then 1997, Log Glover developed a quantum search algorithm with O n under root n complexity. So these are the integrated part of any quantum computing machine, where we are going to use the same logic to understand the functioning of quantum operator. So let me tell you the overview, which comprises introduction and history, then how the data is represented, then the operation of data, so algorithm and conclusion. Yeah. So when we are talking about the transfer of information, and this transformation of information basically in computer, it is done in bits. We are that bit is used for transfer of information in the computer. But in case of the optical computer, the unit is called qubits or quantum bits. So what is this quantum bits? The quantum bits basically represent the 0 and 1 state. And the single bit is also known as qubit. So what is the logic between 0 and 1 state? I will tell you. Because you see here, this is a universe where we have the electron and this is the excitation. And this is the excitation where electron is moving. Now what is the possibility? Because there is a force that is called the Coulomb force between the nucleus and the external electron. And as a result of the balance of the charges, it stay in the orbit. Now possibility that when you do a light pulse, this electron will jump and it will move to the outer orbit. And once it is moving to the outer orbit, it releases a photon because of the transition. And this photon is known as E is equal to ST. That you already, as you are aware of this thing, E is equal to ST. The reason is that if you see the nature of photon, the entire world is divided into two parts. The world of physics is divided into only two parts. One part of the particles are known as fermions, and other part of the particles known as bosons. So fermions particles are having half spin, half, and the boson particles are having one. This is the fundamental difference. Since protons comes in a boson form, so you got your clue that the mechanics or the system can be developed where you can take the logic of 0 to 1. That is the most significant consideration related to the quantum or qubits. Qubits means when we are talking about any system, the zero energy or ground state is known as the zero state or K2, and the excited state you can tell 1, 0 to 1. And moreover, the 1 is also associated with the what is called the boson character of a photon. So you are satisfying two aspects of a physics. One, the zero state is already zero, and other state, the nature of the particle or the nature of the photons, which is one. Right? So your qubit system basically operates into this. So now when we are talking about this qubit 0 to 1, and when we are talking about quantum mechanics, really it's a very difficult and complicated topic. And I think it is difficult to explain everything in a small lecture. But you can see that when particle is moving with the wave, so possibility is that the wave and the particle can occupy any position on the wave. It may be on the top or the bottom or any side. And because of that, we can say this is a probability. I mean, this particle can exist anywhere between any position. That's why when we are talking about the location of a particle in the system, it is represented by a what is called probability factor, that is called psi. So psi is the factor. Now what is happening when the waves are moving in the system? What is the possibility? These waves can interact with each other. Like a law of superposition. You might have studied, maybe I will show you the slide, what is called the double slit Huygens experiment, where you can find that one light source can be converted into a monochromatic source. I mean, you can produce two sources, and those sources are treated as a coherent sources. So when you have the coherent sources, then what are the possibilities? You have the photon. This photon is creating another pair of the photon. They are identical in nature. And that is called the entanglement. Suppose you have a cup of tea. You made a cup of tea, and that tea you put in transfer into 2 cups. One side you can add more sugar, other side you can put less sugar. But both the tea belong to the same source. So tea basic character is same, but if you taste it, the character is different. So this is called the entanglement. Similarly, when we walk or when we see, our shadow is also there. This existence of shadow is calling, that is the entanglement of the person. So entanglement is basically used, and this entanglement basically showing the relationship between two systems. Here the relationship exists between 0 and 1. So that is called the superposition of the two states, which is denoted by the addition of state vectors, and which is given as alpha 1, beta 0 plus alpha 2. So this is basically telling you the probability where alpha 1 and alpha 2 are the complex numbers. So anyhow, let us not go in the complexity of the complex number. Yeah. So now, when we are talking about the superposition, what is the possibility? So one is that when the light pulse is falling, the electron is excited, jumping. Now there is a possibility, two possibilities. One, it will go to this stick. You have the stick. Nahi, stick nahi. Okay. So one possibility is that it will go to the outer, and the second thing is that when we talk about stability of the system, no
So
problem.
we will shift that thing. Not like
No.
so that
No. Okay, that's all right. Good. So this is known as a zero state. When it is jumping, it is going to the one state. the excited electron cannot stay in external orbit for the longer period of time. So it will try to come back. And this process is like a oscillation. When the proton when light is falling, it will be excited, it will move from ground state to excited state, and excited state to the ground state, some sort of oscillation. It means finding the position of the electron is the sum of F0 plus. That is known as a superposition. That can also be understood by using a law of optics. So this is applicable for 2-bit system. Suppose you have a 3-bit system. Now because when you are going for a quantum computation, bits number has to be increased. Then only you won't go for the complicated, faster calculations. So this psi can be 001, 1 probability, then 001, 111 divided by root 8. And then you will take a multiple permutation and combination of 001 or 110 states. So in general, when we are talking about the n qubit register system, it can be represented by the law of 2 raised to the power n minus 1. So this is basically you go for 2 raised to the power n or 2 raised to the power minus 1. Why it is there? I will tell you the reason. Because this is coming in a case of an electronic system, you can directly control. But when you are talking about optic system, you need additional, the requirement, additional photons. That only help you to communicate system from one end to the another end. That's why it is 2 raised to the power n. So when we are talking about this quantum entanglement, we are talking about the correlationship between the two, qubits are 2 states of a superposition. Okay. So this is the basic information. Let me give the brief flavor of how the system developed, and then I will explain each and everything in a more rigorous manner. So if you see the evolution of quantum theory and quantum technology used for a quantum computers. So foundation was laid down in 1900. So 1900 was the year, and 1906 the Planck came in the picture, and he has given the dual nature of the particle, wave and the particle, and that was established in 1906. You also know that Albert Einstein got Nobel Prize. That is also in year 1905. So these were the 2 strong developments. And in addition to that, another person came, Schrodinger. So Schrodinger was the scientific advisor of Hitler, and he was not getting more respect in the scientific community because of his association. And Schrodinger that time has given the law of uncertainty. That is a very this thing. And then his equations are also known as what is called Schrodinger equation. So these were the fundamental development which took place between 1900 to 1925. 1929 was the year where the Dirac came in the picture. And Dirac was basically, you can say, the founder of a quantum mechanics. And he has given the quantum nature, and he defined it, how it can be defined. And after that, 1935, EPR paradox came in the picture, and this was the basically, and people started about the quantum enlargement, quantum theory, use of quantum, and it was the 1965 when the Feynman came, and he basically given the theory of quantum electrodynamics. So this is the period of 19 to 1965. Now we do the second part, this is 1980. Where you can see the quantum cryptography or IBM came in the picture. IBM proposed a phenomenon of computers because he was a very deep thinker, and he has projected many things. The nanotechnology, it is his contribution. Hyman's. Yes, Hyman told during this 1960s, 65, that there is a space in the bottom, and that space is nothing but a nanoparticles. So now you see the entire revolution came in the science and technology, and that prediction was also made by the Hyman. So Hyman was the person who is basically given the hypothesis or the what is called the idea that the quantum physics can be used for making a quantum computers. And when you are talking about all these things, you need some analogy because you are dealing with the electrical and electronic system. How electron photons can be converted into electronic system, that is the one thing. And when you are going to convert it, there is a process. And that process cannot be possible until unless you have certain law. And that law is called nonlinear optics. Because the linear optics everybody knows. 17th century or 1668 and onwards, when the Newtons and what is called Huygens demonstrated what is called the propagation of light phenomena, superposition of the waves, conservation of the energy. So these all phenomena are basically, excuse me, if you are not interested, you can leave. Okay? So the waves can interact with each other. Where they are coming in a phase, they will extend energy and the resultant amplitude will be enhanced. And when they are coming in opposite phase, they will destroy each other's energy because they are in opposite phase. So phase concept was basically well defined. But when the phase came in the picture, the thing was you should be having a machine, a device, and that was the laser. So laser came in 1960. It is called Ali Jawan and CS Towns. These were the people who made the first what is called helium neon laser. So that was a revolution in the field of optics. Once the laser came in the picture, then people started thinking about the coherent states. And when the coherent state was there, the people were thinking when the light is moving through the medium, can quite disturbing. So, light can be converted into some other frequency. That is the question. Suppose we have a light of frequency omega, when it is passing through a medium, can we generate the photons of high frequency or the lower frequency? And that becomes possible by a simple experiment, and the theory was given by Professor Blomberg. And 1982 Nobel Prize was given for the explaining the phenomena of nonlinear optics. So these are the background of your quantum computer machine, where the laser came in the picture, the conservation of energy and momentum was explained in the medium using a law of what is called nonlinear optics, and then simultaneously people have decided to explain the qubit system, which can carry the information from one state to the another state, right? So this was the year, and during that period, solar algorithm was grown, and then these photons, 2010 and onwards, the people actually started working on this system. So it was actually 1984, 82, 84, Hyman was alive, and he has given the model of quantum computer. And then gradually you can find there was a lot of development, because what is called the D-wave announcement. Then 1916, IBM has made a qubit QC system, cloud portal. Then 17, you have got a 2000 Q system, 17. So these are the era, and now you can see we are now 2021, 23. So this system is now already came in the picture, right? So this is the whole history, which is very important to know. So, which I already told you, what is the quantum computing? So basically, quantum computing mechanics is a theory which describes the behavior of a microscopic system, because electron, proton, photons, they are all microscopic particles, and this theory has extensively been used or tested by the experimentalists to show the probabilistic nature of a photons, right? So this is a whole what is called the basic science, or what is called the assumption used by people, and this is, many of you know or don't know. So this is the Schrodinger equation, which basically defines the time dependent h e into ut divided by h plus. So this equation basically correlates the psi function with respect to time and homotopy. So when I was talking about the quantum entanglement, so the entanglement is the ability to quantum system to exhibit correlation between two superposition, which I already told you. A simple example is the case of a two Prof of chai. Like a two chai, where one is strong and another one is weak, and poured in the similar cups. So when we see from the outside, chai is looking identical, but their nature is different. But they belong to the same. So this is a very, the simple representation of explaining the most complicated process of quantum entanglement. Yeah. So when we are talking about this entanglement, the simplest, the classroom teaching, you can say, when we start teaching first year student, we always talk about double slit experiment, light. So we have the source, and this is the two slits. What is happening? There is a lot of possibility. This photons can go, and it can, you can see on the screen. But if the distance between these two slits are at certain distance, if they are very small and very close to each other, what are the possibilities? Yeah. So as a result, you will get two waves, one and two, and they are basically intersecting each other. So this intersection, it depends how currently they are connected to each other. If they are really in a perfect phase, this intersection will be some sort of overlapping. Otherwise, it will go, or there is another possibility that two waves will be separated out. So, when both slits are open, this is ultimate resultant, where you can see a small bit and because of this. So this is basically explained with the part of a bullet. Yeah. Now let us take a wave, because that was a classical approach. Now we are jumping into the field of optics. So these waves basically move and then interference with each other. These are the quantum interference, where the energy is propagating. And when the energy is propagating, means the energy distributing on the screen, the system. And when they are meeting in a phase, it is called the constructive, where you will get a bright fringe. And when they are in opposite phase, you will get darker fringe, that you already know, because it has been taught in your 12th standard also. It means, as per the law of conservation of energy, energy can neither be destroyed. It means the energy distributed. It distributed in two parts. One is maximum or the minimum. So, yeah. So now we can see how the data representation is done. we are talking about this quantum integral space, this is defined in terms of 0 and 1. So this is basically when it is used, it is called unitary transformation as a quantum concept. Unitary transform is basically a technique when you go for a matrix multiplication or vector multiplication. What is happening? The vector quantity, they will multiply it with each other and remain vector. Because their inherent nature is not going to be changed. And this type of transforms is also known as a unitary transform. And possible I will give the example how the unitary equals. So you know when you move from 0 to 1, these are the levels. And then you can keep on changing the time. T, T2, T1, Tn. So by this way, our transform is one matrix can be multiplied or added to the another, and these operations can be done using 1 to 2, 2 to 3, 3 to n. So this is a fair possibility that the quantum measurement is a total can be defined in terms of phi psi m square. This is the whole, basically the mathematics used for your quantum computation. Yeah. So when we are talking about this quantum bit, qubit I already told you, and realization of qubit bit is also you can see in different type of scientific devices. One is called Google IBM, the superconducting loops, where we have the induction and the capacitor, and the current is flowing. So this is basically some sort of a resonance system. And when we use the resonance system, what is happening when the Q of the cavity is high, we will get the highest signal. That is also followed in any designing of any machine. And then similarly, this is another example where we are talking about the laser system. Then this is the microwave system, and this is a particular topological qubits in a time domain. So I will show you how it is working, how does it work, and how it is associated in the. Yeah. So when we are talking about the qubit, the obvious question is that how can distinguish two photons? The photons are identical and they are already defined because they are bosons. Boson 1 or 2. This is the possibility. So these bits can be basically there are two photons. So when light is moving in the system, what are the possibility? It is a polarization. I mean the vibrations. One vibration is the plane, parallel to the plane, and other one is the perpendicular to the plane. I mean that is the actually the reason there the light or the T up to different tests can be identified whether it is sweeter or the less sweeter. Similarly, when the polarization concept came in the picture, it means you can divide whether light is a P polarized or the S polarized. So it is a combination of two photons. So this is called horizontal and this is called vertical. But they are the part of the same photon. It means the qubit system is now applicable. Right? Now when qubit system is applicable in reversible computing, the ancillary bits are extra bits. So the reason is that when we are talking about this qubit to work for you in a computer, you need additional bit that is known as ancillary bits. What is this ancillary bits? I will tell you. This is the bit because you know when the light is propagating through the system, now there is a possibility they can interfere with each other. And in order Hello? I am in a meeting. So, how you can do this thing when light is moving from a system?
how you can distinguish or how you can make that they can work together. Only thing is that you can use the polarizers. The polarization is the process which can change the rotation of the light. The light which is basically horizontally polarized can be converted into the vertical polarized, or vertical polarized can be converted into the horizontal polarized. And when the polarization is same, or we can make it to be same at certain angle, then what will happen? The photon will start exchanging energy with each other. And that is called the quantum entanglement between the two photons. Right? And which is the essential part of your quantum computer. So in classical computation, any memory bit can be turned on or off at will. Because if you have the system, you can change your memory, can be also make it on and off, requiring no prior knowledge of extra complexity. However, this is not the case in quantum classical recursion. So reason is that in order to do this thing, you need extra optical device that is called a polarizer. Now, second question. When we are talking about these photons, we are talking about a single photon. It is not a multiple photon. Single photon can work, not the multiple photons. In order to get, you have to have a device which can act for a single photon. So now lasers are available. They can generate a light which can help you to get a single photon. And not generation, detection is the most challenging. Because single photon is very weak in nature. In order to detect that thing, now the detectors are also available which can detect a single photon. In my laboratory, I purchased one pair of detectors which can be used for detection of a single photon. Yeah. So when we are talking about this linear optics, quantum control, not. So when we are talking about any computer system or any microprocessors, your optics or electronics basically works in terms of gates. AND gate, OR gate, NAND gate. Universal is the NAND gate, right? So your optics system has to be converted into a gate. And this is the gate concept of your qubit. So you see, this is a two input. One is called the control, other one is the target. It is passing through a black box. I will tell you how this black box is there. And this is the output. And these are the two detectors, 1 and 2. In between there is a ancilla pair. This is nothing but a pair of a generated photon. So what is happening when the light is coming from target? You can see what is this. So polarizer, na? Yeah. And this is also, so you can basically select a polarizer, right? And this polarizer can pass through the beam splitter. And here you can get a one detection. Other side you will get a output here. So this basically gate what we are using here, it is a quantum control NOT gate. It is also known as control NOT, C NOT. It is not NOT gate in optics. It is C NOT. Why control? Because they are controlling with the help of an ancilla pair of the photons. So these photons basically helping you to control the what is called the polarization of a single photon, which is one which is coming from a target and other one is coming from the control. And using the combination of what is called your polarizers and the beam splitter, you can find a state where you can get either one or the zero. Right? So how? So what when we are talking about ancilla, ancilla is nothing but a garbage. Garbage means the residual thing. So what is happening when they are interacting, these photons, two photons are interacting within the system, there is a possibility that their energy will be reduced because they are already single photon. So single photon can lose its energy. In order to act and become effective, you have to supply something, and that comes to the ancilla. The ancilla photon basically compensates the losses between the interaction of two polarized photons. So that is basically the part of a Naveen. Is it all right? Huh? So Naveen is my scholar. So he is working on artificial intelligence, there are imaging. So I think how many of you are working or not, but at least I get consent from Naveen. Naveen is okay? So what is happening? So now you have the states C1, C2, C3, C4, C5, and here this garbage system, NCLA, which is a reserve system. I mean that you need. When it is not there, you cannot get the proper output. You need the output in 0 and 1. Then only your bits will, or qubit system will work. Otherwise, it will not work. So in order to act, you need this thing. That's why this system is little bit complicated, and that's why it took time to get a supercomputer or optical computer in 2017 or 20. Yeah. So when we are talking about this thing, last time I defined what is called the unitary transformation. So this is a mathematical operation because when you are designing a system, there are a lot of mathematics in there. Because computer designing is not a very simple task. And when we are dealing with the optics, it means you have the combination of quantum mechanics, you have the big matrix. Because my scholar knows that many of you those are doing research. For designing a system, your data is huge, and that data basically required to be calculated by in a different way. So in order to do this thing, this transformation becomes very important. We are also using the same transform, and Naveen is going to show you converting data into the image. The same thing. So you are getting a information in terms of a matrix. Matrix may you get m into n number. It may be 2, 2, 2 by 2, 2 by 4, 4 by 4, or m by n. M is equal to n, m cannot be equal to n. So all possibility. So this matrix basically store the information about the what is called pixel. The word I am using a pixel because we are using a mobile phone, right? And market mein you are paying money for a better camera based system, right? A smartphone and all. So what you say? What is the bits? 6 megapixel or 10, 100, whatever. Accordingly, the price will go up. What is the meaning? I mean that this bits basically control the information. If the higher is the bit, it means the picture is good. You look more beautiful, more smart. That's why the people use a very good quality camera. So it means you can compress more amount of data. And this data has to be transferred through your qubit to the computer for doing the mathematical calculations, right? So, when we are talking about this thing, the word Hamiltonian is coming. The Hamiltonian is actually the part. Hamiltonian, when we write, it has a two part. One part is called what is called potential energy. Other one is the kinetic. It's a combination of two. And combination of two means any system. When we are talking about, suppose you take a ball and you jump, it go up and then it will come. So what is happening when you are jumping it up? This kinetic energy is increased. When it's coming down, the potential energy become more, right? Similarly, when you are dealing with any quantum calculations, your system should have a combination of both kinetic and the potential energy. So in modern days, whatever research is going on, you will find people are more emphasizing on the potential energy part, where there is a lot of scope, where the potential energy section can be modified to reveal the many important and hidden information from the system. Yeah, so this is a real-time, quantum computer. You can see the photographs, and you will find light because it's an optical system. You see how optical systems are being arranged. So this is one of the latest Chinese 76-qubit photon-based quantum computer, and this is IBM 53 qubit. You can see this is the whole designing of a quantum computer, where you will find lot of multiple optical sources, polarizer, beam splitters, detectors, and then ultimately the entire system works as a computer. So don't worry, it is coming in the market very soon. Yeah. talking about this thing, quantum bit, qubit form, it is 2n minus 1, I told. This minus 1 is basically representing the ancilla, because that is the bit information we are providing to the total interaction. This is 2n. That's why it is used as 2n minus 1. So, कैसा multiple qubits you can see. Yeah. So now it is a 1-bit system. This is 0, 1, 2, 0, 0, 0, 1, right? 1, 0, 1, 1. 3 bits. So these are the permutation and combination of multiple bits can be done in the same form what we are doing. And this is superposition is given by 2 raised to power n. But when ancilla is coming in the picture, it is 2n minus 1, because the additional thing is provided that should be subtracted out from this equation. Hello? Lot of undesirable calls. They want to give you money, loans, so many things, land. Yeah. And this afternoon business is that every time you get a phone call, अरे भाई देना है तो उसको तो जिसको जरूरत है, आप मेरे को देंगे क्या करोगे? But ले लो आप लोन, मुझे नहीं चाहिए तब भी ले लो आप. So when you are talking about this thing, no business. I do not know how they are getting number and calling me. कभी-कभी क्या होता है, आप रजिस्ट्रेशन करने जाते हैं ना फ्लैट का, तो वहीं से इंफॉर्मेशन आ जाती है. वो आपने एक डील क्या कर ली, इट इज नाउ यू आर एक्सपोज टू द मार्केट. ये बंदा जो है नेक्स्ट वीक खरीदने की कोशिश करेगा. तो when we are talking about this unitary transform, so now again come back to the your laptop system, where you can have psi 1 to psi n. I mean these are the input, and this input basically interact inside the system, because the interaction I already told you how it is working for a single system. So this type of, and then you can get a desired output. It means your computer is ready for the operation in the optics form. I think am I clear? What information I told, I don't know whether you know this was optics or not, but I try to take it through of very basic optics. I don't know more basic than this, but since many times I have to teach integrated students, वो जो 12 से आते हैं ना, और खासकर का भी कोविड बैच वाले आए, तो ये तो मतलब कि आप सोच लो कि सबसे बड़ा जो टेस्ट है टीचर का, ये कोविड बैच को पढ़ा करके फिजिक्स समझाना. हाँ, आगे है वो बिल्कुल ठीक है, बट वो आपका सारा नॉलेज जो है टेस्ट कर लेते हैं, और अगर आपने उनको समझा दिया तो इसका मतलब है कि यस यू नो समथिंग, क्योंकि कुछ नहीं आता है बट दे नो एवरीथिंग, क्योंकि सबको 99% है. अभी सेंट्रल यूनिवर्सिटी में दे आर सिलेक्टेड, राइट? तो सबका स्कोर देखेंगे तो यू विल फाइंड 99.5. एंड हाउ यू कैन डेयर टू टेल दैट दे आर नॉट गुड स्टूडेंट? पेरेंट्स को तो एक मालूम है कि भाई मैं सन एंड डॉटर बहुत 99%, दे आर वेरी गुड स्टूडेंट. अब वो कैसा आया यू नो, राइट? अभी टीचर इज नाउ टेलिंग, वो बिल्कुल समझ में नहीं आता उनको कुछ भी. तो बहुत ही डिफिकल्ट सिचुएशन है दोनों साइड में. मतलब जो बच्चा क्लास आ रही है, मतलब 12th वाले, उनके साथ तो ठीक है, उनको आप 3-4 साल 2 साल में रिपेयर मतलब ठीक कर दो. और वो जो मास्टर्स करने आ रहे हैं बहुत डिफिकल्ट है, क्योंकि वो उसके बाद PhD करने आ रहे हैं, वो भी ऐसे ही आ रहे हैं. तो इस समय मतलब आप समझ लो 22 के 20 कोविड के बाद से ये जो जब से ओपन हुआ यूनिवर्सिटी, लाइव टीचर्स की जो है वो एक टीचर ही समझ सकता है. I cannot tell. Many of you are a teacher also. You can understand, because it's not a problem of my university or your place or your college or university. Everywhere the problem is same. ठीक है, अब ये है कि आप उससे क्वेश्चन मत करो, ठीक है। पहले भी लोगों ने क्वेश्चन नहीं किया, हमको पास कर दो अच्छे ग्रेड देके, तो लोग बोले यार इज गुड टीचर। आपने क्वेश्चन किया, फेल हो गया, नंबर कम आए, तो फिर वो बोलेंगे नहीं टीचर इज नॉट गुड, राइट। तो यू शुड बी रेडी टू लिसन दिस कमेंट, नो प्रॉब्लम, क्योंकि भाई मैं तो सरकारी सिस्टम में हूँ, गवर्नमेंट में, राइट। तो हम तो किसी को प्लीज करने के लिए काम करते नहीं हैं कि आपके पेरेंट्स खुश हो जाएंगे तो बोलेंगे अरे सर अच्छे हैं। भाई आप खुश हो नहीं हो, पर मेरी खुशी है कि आप सब्जेक्ट जानते हो कि नहीं, राइट है ना। ये प्रॉब्लम यूनिवर्सल प्रॉब्लम है, और वी आर फेसिंग। हमारे अपने बच्चों को भी देख लीजिए, वो भी ऐसे ही, आप बाहर क्यों जाते हैं। तो चल रहा है सिस्टम, अब मेरे को लग रहा है कितने साल चलेगा, पर इस समय जो है क्राइसिस तो है। तो दिस इज ऑल अबाउट योर क्वांटम कंप्यूटर। अभी आप इतनी एक्सरसाइज कर क्यों रहे हैं, व्हाई यू आर डूइंग दिस मच, व्हाट इज द एडवांटेज। तो मेन एडवांटेज क्या है, केमिकल सिग्नेचर। बिकॉज अभी जो मार्केट में जितना भी स्ट्रक्चर, ड्रग्स, मॉलिक्यूल्स, जो केमिस्ट्री होती है, दे यूज बेसिकली क्वांटम कंप्यूटेशन टेक्निक्स, that is called Gaussian or first principle based. And Naveen is here, even we use a small molecule of TNT or RTS for calculating the different mode of their chemical. It takes 3 months to 3 months time. When you put on a computer is on for day and night. So minimum calculation take place 2 months time. And as a result, many information or vital information basically we do not get because of that reason. People don't want to work because they don't know 3 months who will do. 3 months the student should be dedicated, regular, वो नाइट में भी दिन में भी उसको चेक करना मॉनिटर आकर के, कहीं हैंग तो नहीं कर दिया कंप्यूटर। बट अभी कोविड बैच के लोगों से आप बोलो काम करने को, will they work? They will never work. So reason is that is a main the hurdle. So when this computer comes in the picture, when now it is coming, so this computer calculations become very fast. So information which is taking 6 months time or even 3 months time, that can be revealed or can be done in a small period of time. Optimization. So when you go for this thing, optimization and weather forecast, that is most important part. Because nowadays we are already getting information. This optical computer is now involved. You don't say you are, because every type of cyclonic things comes in a different name. El Nino effect, what is known as El Nino effect. So we get a very clear-cut information. When it is going to come, what will be the intensity, at what hours it will be intensify, what will be the disaster. Everything is known. From where this information is coming? Yes. So this quantum computer is involved now. So IBM and other companies, they are basically involved to do all these calculations. Then you say how you can predict. So this is called the artificial intelligence. Because a lot of informations are stored. This information is basically correlated, and ultimately the right information is given to the common man. So this is the most, the things, what is called the machine learning and this quantum computer application. So let us come to the operation of the data. So this operation of the data, you already engineers, this thing better than or equal like me. Because I am a physicist, I used to teach electronics. This electronics, this is a NAND gate. So this NAND gate logic you can use, right? And we can see the output, right? So the C is basically multiplication of A into B, right? Then only 1 into 1 will be 0, or 1 into 0 into 1 is 0, or 0 into 0 is 0. So this is a, the system which is basically used in a reversible qubit things in a form of 0 and 1, what we already shown you or discussed. So, yeah. So, when we are talking about these gates in optics or quantum optics, it is called Hyderabad gates, quantum gates. Then we know that Hyderabad gates. So they do the same applications Institute of Electronics, you are doing an optics, so this is a zero state, rectangle 0 plus 1 are 0. So this HADMAT gates basically help you to separate the information like an AND gate. Either you can 0, 0, 0, 1 or 1, 1 or 1, 0. So by this way, you can get your NAND gate or C NAND gate, C OR gate, every information you can basically separate. Yeah. So when you are talking about this thing, this is another refined part which I already told you. Target and the control. And the same process is used 0, 0, 0, 0. So these are the the possibility of doing quantum calculations.
Sir, if you don't mind, can you take the 15 minutes tea break?
Now,
Yes, sir.
how you can take tea break here? Yes.
3:30 to 3:45.
Okay, yes.
So,
Tea is available here.
please join after
Okay.
15 minutes. You know?